Intermediate Algebra for Statistics, Factoring Out the GCF, Part 2. Lesson Objectives. Factor out the greatest common factor, GCF, of a polynomial. Factor polynomials completely. We'll begin with an example. Factor 4x squared minus 24x minus 28. We see that a is 4, so our first step is we want to make sure that 4 will factor into each term, and it does. 4 is a factor of 24 and also 28, so the greatest common factor is 4. Factoring out of 4 for each term gives us 4 times the quantity x squared minus 6x minus 7. The next step to factor completely is to make sure that this trinomial does not factor. So what two numbers will multiply to give me a negative 7 and add up to give me a negative 6? So if you recall, when c is negative, so we'll have one factor that's positive and we'll have one factor that's negative. Since 7 is prime, it only has two factors, 7 and 1. And since we want a negative 6, a negative 7 plus 1 is a negative 6. So that's our factors. So we have 4 times the quantity x minus 7 times the quantity x plus 1. To verify this using our graphing calculator, we type in the original problem in y1 and our answer in y2, and we use our table feature. We see that y1 and y2 are equivalent. Next, example 7, factor 4x to the fourth plus 7x cubed plus 12x squared. So in this case, a is 1, but we have an x squared, an x cubed, and an x to the fourth. So that means we can factor out the smallest power in each term, which is 2. So we have x squared times x squared plus 7x plus 12. Our next step is to factor this trinomial. C is positive, B is positive, so both factors will be positive. So what two numbers multiply to give me 12 and add up to be 7? Well, that would be 3 and 4. So therefore, our final answer is x squared times the quantity x plus 3 times x plus 4. To verify this using our graphing calculator, y1 will be the original equation, y2 will be our answer, and using the table we see that they are equivalent. It checks. Example 8, 5x squared minus 45. Since a is 5, we want to factor 5 in both terms. 5 will go into 5 one time. 5 will go into 45 9. Now to factor this completely, we want to make sure that this doesn't factor. If you notice, this is a perfect square, this is a perfect square, and we are subtracting. So this is a difference of squares. So if you recall, x squared minus 9 factors to x minus 3 times x plus 3. So our final answer is 5 times the quantity x minus 3 times the quantity x plus 3. Now you may be asking, why is factoring important? We'll see in future videos that this ties into graphs of polynomials. To verify this on the graphing calculator, we type in 5x squared minus 45 in y1 and in y2 our answer, and we see the answer checks. Our last example, factor x cubed minus x. Solution. Now here we have x times x times x, and here we have an x. So this means that we can factor out an x for this binomial. And when we factor out an x, The x cubed becomes x squared, and the minus x becomes a minus 1. Again, if we need to verify this, we can do our distributive property here. X times x squared is x cubed minus x times 1 is x. So these two are equivalent. If we notice here, this is a difference of squares. This is a perfect square. 1 is a perfect square. So this factors to x minus 1 times x plus 1, and that's times our greatest common factor. Verifying this on the graphing calculator, we see that these two are equivalent. The answer checks. Thanks for watching.